Okay, let's say we're given an equation like so, and we're given a zero. And what's special about this zero is that it has an I, which means it's an imaginary. In case you don't know, I equals square root negative 1. Okay, so our task is to find the rest of the zeros. The first thing we should do is look at the degree of the equation we're giving. This one is 4, that means we're gonna, basically, we might have 4 zeros. Actually, we have to have 4 zeros, to be honest. Alright, let's get started. First thing you want to do is you want to get the conjugate of this zero, which is going to be negative 3i. Not, and then multiply them out. And just basically distribute them. Or use FOIL, whichever one floats your boat. These two cross out and we're left with is 9i squared. I squared becomes negative 1. So that'll give us, and if you simplify that, you'll get x squared plus 9. Now our next step is to basically use long division and divide this equation by our answer, this one. The reason I put the 0x here is as it's a placeholder, so you know since you're long dividing, you need to write down all the values. Like you can't skip one. This is a degree 2, and this has no degree, and we were missing the first degree, which was right here. Then what we have to do is we have to divide that by this. So just write that down. Okay. So this is what you have now, and you can just basically use quadratic formula to find the two solutions for this. Once you use the quadratic formula, which is negative b plus or minus square root of b squared minus 4ac over 2a. It's a quadratic formula in case you forgot it. And let's just quickly continue there. You get the answers 1/3 and negative 2. So now we quickly go back here and look. We have these two zeros. And after doing the quadratic formula, these two zeros. And those are our answers. Alright. Alright. Now what we're gonna do is we're gonna find the zeros again for a much harder question. Now for this one, you can't easily tell what makes this one equal to 0. So if you remember when we did this, when we got with the p equals and all the factors of 75, we went to like plus minus 1, plus minus 3 plus minus 5, and so on and so forth. And q, well, the factors of the coefficient of this one, which would be just plus minus 1. And we gave all the possible zeros. You just basically do that one and just just keep checking these numbers until you get one that works. Well, and we're using synthetic division. For this one, -3 works. Now let's just quickly use synthetic division to prove that. And no, there isn't an easy way to tell this. You actually would have to go through all the possible ones and figure out which one works or not. You see, when we use synthetic division, we got 0, proving that -3 is actually a 0 for this. It's a factor for this. So we would just do that. So we x plus 3, and then now you would repeat the same step we used for this one for this equation. So we would again write down all the possible p's, which would be the factors of this. That's plus minus 1, plus minus 5, and so on and so forth. And q would be the factors of the coefficient, which is 1, which would be plus minus 1. And try again. Do the synthetic division again for this one. Turns out 1 works for this one. Just going to use synthetic division to prove it. So we got no remainder again, thus making this also a factor. Now you can easily solve this one if you just make it x squared plus 25 equals 0. And again, since it's a negative under the radical, it's going to be an imaginary, which will be (5i). So now we just scroll up. It's degree of 4, right? So we need 4 zeros. Our 4 zeros are going to be -3, 1, 5i, and -5i. Alright, hope this helps. If you have any other questions, leave a comment below. Thanks for watching.